Hello everyone, I'm Brad Henson, and in today's video we're going to finish up with the power supply upgrade series. It's been a long road, but I'm happy to say that I finally have a product or a unit that I'm happy to show everybody. It works extremely well. It definitely will meet my needs, but we're going to see here in this video that it's not a 100% solution. This is the circuit board that I have in here for the variable power supply. Is the very first circuit board that I personally have ever etched, and it was also the first circuit design I had ever done. And so I've definitely identified some weaknesses in there. I've also had a couple goofs in assembly, and I'll show you those as well. One which I still have to fix. To start off with, I figured we'd take a look at some measurements here on the bench, and then take the cover off and take a look inside. And so with our little setup here, I've got the multimeter tied to the variable output, set to 10.225 volts. As you can see on the multimeter, we're almost bang on, just 4 millivolts off. And then I've got the constant current connected to that same output. Now, one of the problems I've seen is as I increase this the load on the variable output, my voltage reading is going to drop by I want to say it was 400 millivolts. So we'll take a look at that. So I'm going to crank this up. I plan to use this power supply at between 2 and 3 amps max. So there's 1 amp. So at 1 amp I'm already off by 300 millivolts. And if I continue to increase this, at 2 amps, I've now dropped by half a volt. This isn't meant to be a precision power supply, so for my purposes, I'm okay with this. This is a learning experience. I definitely need to get in here and figure out what I can do better in the design to avoid this problem in the future on my next power supply. But right now I'm happy with it. I'm definitely happy with the new current meter. As you can see, the output from the panel meter and my constant current load are very close. I couldn't be any happier with that. So even though I would like to test this power supply up to the 3 amps, unfortunately the constant current load that I've built, the voltage reference in it is set so that the max I can get is 2 amps. And so that's something I'll have to correct in the future for other builds. So the next thing we'll take a look at is our output on the 5 volt dedicated rail. And we did a little bit of testing on this in our last video. As we can see, we're bang on 5 volts as expected. I'll go ahead and hook up the constant current load and see how that looks. And again, we're only looking to use this 5 volt rail for up to half an amp. And so at half an amp, I'm sitting at right at 5 volts. That's perfect. I couldn't be happier. And again, you know, while this power supply is under a load, I do see a drop in my voltage, and it's something I'm going to investigate and see if I can improve upon in future designs. Now that we've had a chance to take a look at the outputs, I say let's crack it open and take a look at the inside. Now on the inside, I've tried to keep everything as clean as I could. Now keep in mind, this is a do-it-yourself, one-off project, you know, learning kit. So it's not going to have that perfect finesse that you're going to see with the printed circuit boards and modern, you know, electronics. One of the first things you might notice is that I use a lot of salvaged parts. You know, right off the bat, taking a look in here, my AC transformer is salvaged out of an old radio. My heatsink is salvaged off of, you know, I don't remember what that came off of. I think it was like a security applications electronics device. I've got some other heat sinks, like this one on this board is salvaged. A lot of my capacitors here are salvaged. All of the wiring in here, just about 100%, with the exception of this solid core 22 gauge wire, is all salvaged from old electronics. So we'll start in the back and move our way forward. You'll see we have our mains input going down to a terminal block. This is the first time I've used a terminal block in the power supply, and it really is helpful for having nice clean connections so that you can run wires to the front panel for your switches and then run your wires to your transformers. I'm definitely glad that I went this route. I didn't originally plan to use it, but during the build found that it was almost a necessity. Of course, like as I mentioned, I've got my mains wiring running up to the switch. I'm not using any kind of color-coded wire. I try to keep things so that I understand it. You'll see my red lines are the neutral lines. The white line is the hot line, and then this blue wire is mains ground. From the mains plug, I've got that blue wire connected to inside the two transformers. See if you can see that. And then that wire is running up to the front of the panel to the center ground post, so that if I want to run this power supply as an isolated power supply, I can, or if I want to connect it to mains ground, I can as well. I've got that option. Now over on the heatsink, you're going to see my first goof. I've got this power regulator. This is my 7805 voltage regulator. When I first put this power supply together, without thinking about it, I connected both the 7805 and my variable voltage regulator, which I'm using a 1084. It's a pin for pin swap with the LM317 that I was using, but it has a much greater current rating. It can go up to 5 amps versus my LM317 was only good for an amp. And so when we increased our mains transformer to 3 amps, I had to find another solution for the variable voltage regulator. Well, when I first put this together, I mounted both these regulators to the same heatsink, and it defeated the purpose of having the separate channels. You know, I needed a second channel to power the amp meter so that it didn't share a ground with the voltmeter and the main power supply. However, the tab one, the 7805, obviously is the ground, and so I was making that ground connection on the heatsink, and when I did my initial measurements, I was noticing that when I'd measure the output of the 5-volt rail, it was getting the output of the variable rail was being added to the 5-volt rail. And it took a couple minutes to realize that, oh man, I goofed. And so right now I have it disconnected, kind of free hanging. I plan to, because in our testing we noticed that this didn't produce a whole lot of heat to start with, I plan to just use a small heat sink. I have one right here that I salvaged out of a CRT monitor several months ago, and I think this is going to work. I'll set it down in here, mount it to the board, and then have that mounted directly to it. That's one of the advantages of using these screw post terminals. I didn't solder directly to my boards, so I can easily disconnect this, shorten that wire, or those 3 wires, and mount it somewhere else in the case. No worries. I think that's going to work out just fine for me. It's not as clean of a solution as I wanted, but we live and we learn. Now moving from our mains transformers to the 2 printed circuit boards, or etched circuit boards, you'll notice that I didn't cut these wires short. And the reason for that is, eventually I might want to replace these with more professional or better quality manufactured circuit boards. These are not tinned. The traces on the bottom aren't tinned, and they're not protected from the elements, and so those copper traces are going to start to deteriorate. And so this solution is really just prototyping. It's not going to allow me to continue to use this power supply for years into the future. And so I've left these wires long so that I can disconnect them and put a better quality board in here down the road. Now around the circuit boards, you'll notice that I've tried to keep all my wiring along the edges, and then only coming in where needed to tie into the screw post terminals, and then zip tie it to keep everything as clean as possible. And it's not just so that it looks nicer, but it also keeps it from these wires getting entangled into things like the bridge rectifier or getting caught on the edge of a heat sink. And so I can protect my wires a little bit better by keeping them a little bit tidier. Now, on the subject of wires and the connectors that I use in this build, I'm kind of a cheap guy. I don't want to spend a ton of money on these projects. They're prototypes, they're for learning, and so I try to keep the cost down. For my connectors, I'm using kind of a low-cost solution. I got this 520-piece terminal assortment set from Harbor Freight for just a few dollars. It wasn't much. I have found that these plastic tabs on the connectors really aren't worth a whole lot. And so I find it a lot better to just pull the plastic tab off, insert my wire, crimp it down, and then add a little solder just to make sure that that wire's in there good and tight. And then once everything is settled, I put a little heat shrink over the whole assembly, like you see here, and tighten it up. I'm only a few builds into my career of hobby electronics. I've only got a couple things that I've put together, and I have found that along with the screw post terminals, making it easy to wire and reconfigure things with the circuit boards, is that it is a good idea to put connectors on the other end of all your wires. So anything you're going to connect to the front panel or the switches, rear mains, your fuses, you want to put a connector there. It makes wiring this thing up and building it, putting that final build together, so much easier. It's definitely worth the extra effort to put a couple fittings on the end of your wires, solder it down, put some heat shrink on it, not just to make it look nice and protect it, but also to make it easier for you to build and repair in the future, because these are do-it-yourself kits. There's gonna be repairs. I'm gonna have to get in here and replace components, maybe replace stuff off the front panel, and so I want to make that as easy as possible. Something I forgot to mention when I first started this power supply video series, I had a much smaller case. It really was only big enough for the main, one transformer, the main board, and a much shorter front panel. It didn't take me long to figure out that I was going to need a bigger case, and in the spirit of reusing and salvaging from other things, I've actually salvaged another case, a little bit larger case. I think it's a little thinner than the other one, from another project that kind of went south, and I didn't want to finish it anymore. And so the bottom of this case is starting to look a little like Swiss cheese from all the stuff that's been mounted in it. But this case, these Hammond cases are great. Definitely recommend them. They're easy to find on DigiKey or Mouser. They're inexpensive. The panels, you can buy replacement panels for next to nothing. I'd already mounted a bunch of stuff on the old panels for this case. Went on to Mouser.com and ordered a new set of panels for like $2. Obviously, they're too wide for me to go that printed circuit board or the copper clad board that I had planned, but this is okay. I'm okay with how that turned out. And we'll take a closer look at the front panel and how I went about putting that together as well. One of the things I've done with most of the components in here are mount the stuff directly to the case. It's the mains transformers, the heat sink, this terminal bus bar is all directly tied to the plastic case. However, for the circuit boards, I wanted to elevate them, and to do that, at Lowe's I found these really nice, in the specialty fasteners and tools section, nylon spacers that I can stick underneath all my screw terminals or stick under all my mounting screws and keep those boards elevated. I've used these nylon fasteners in just about every case that I've built so far. They're really cheap to buy. Again, you can buy them at Lowe's. I'm sure they're at Home Depot if that's your store of choice, but definitely worth looking into. So here we're looking at the back of the front panel. Nothing too exciting, kind of using all standard panel mount components. These switches from Radio Shack have a little plastic retaining screw. I wasn't sure about them at first, but I haven't had too many problems with it. And on the front of the switch, they've got a bezel so that they can hide any imperfections in your cuts to the panel. I've got the screw posts or the connecting terminals all from Radio Shack, and they're just using the provided nuts to hold them in place. And then of course my panel meter and voltmeter are the two panel meters, both out of China. They're made exactly for this type of installation. They've got these raised plastic edges that'll help hold it in place once you've got your square cut in. And then of course they obviously have bezels on them on the front of them as well to kind of hide any imperfections in your cuts. And then like the connecting terminals, my 10-turn pots, just using a screw on the front to hold it into place, and then any imperfections are kind of covered up by the knob. On the rear panel, again, I've got my salvaged heat sink. I just drilled 4 holes and mounted some screws to retain it in place, and drilled a hole for connecting the voltage regulator. And a lot of times with these mains inputs, you can salvage these off of other components. A lot of times I get these out of CRT monitors. I think this one I actually bought off of Mauser or one of those component suppliers. And a panel fuse. These things, you'll see on some of my boards that I'm putting fuses on the boards. But one that I expect that if it's going to blow, it's going to blow more regular is going to be the variable, the main output of this power supply. And so I actually have that run all the way back here so that I can easily change a fuse out if needed. Now, front panels is something that I've struggled with since getting into hobby electronics. I've made a couple devices now, and I just haven't been able to make a front panel that was satisfactory to me. And that trend is still going. What I have here is I took a piece of photo paper, so glossy photo paper, and did a design using a vector graphics program. I think I was using Inkscape for this, and did a nice little design and added all the words and my new logo here. But it's, and then I cut it out and used a spray adhesive to apply it to that plastic panel. It doesn't look too bad. I think it's going to meet my needs, at least for the time being. I ended up buying the lesser grade spray adhesive, and I kind of wish that I would have gone with a stronger spray adhesive, because it feels like it wants to peel off a little bit. And then also I think if I got some clear coat, some sort of varnish or something to put over the top of it, it would be better protected and maybe last me a little bit longer. So front panels is a saga that I'm going to continue to try to figure out, and hopefully in my next build I might be able to come up with something a little bit nicer. Overall, this has been a great project. I've learned a lot designing and building, putting this power supply together. I think it's going to more than meet my requirements in terms of what I want to use this power supply for in my future hobby electronics projects. I definitely suggest anybody getting into electronics to start out with a power supply. I mean, you need one for your bench. It's a relatively easy circuit to put together. It's something that can be done at home. You can source your parts, used or buy them kind of fairly inexpensively. You can keep it simple or make it more complex and try to do a finished design like this case. But definitely, dive in. Give it a shot. You're going to learn from your mistakes. I'm definitely learning from my mistakes, and I'm hoping you're learning from my mistakes. Well, we'll see how it goes in the next project. Now, if you found this video or this video series helpful, make sure you press the like button down below, and I'll catch you next time.